As we wrap up 2 modules of hypothesis tests, let's provide a little bit of a brief summary and an indication of where some of all this information can be found in a concise format. First off, just an overall kind of big picture perspective of how to approach these hypothesis tests, and certainly one of the challenges is taking a problem statement, say, out of a book, and then in practice it's even more vague in general, and typically, and figuring out what are exactly the parameters of interest that are parameters also that you can do something with. There's two different questions there of what's of interest, and then what can we do anything with that, or do we have to morph this into a slightly different kind of problem, because that's what you can actually address. Right, so determining the parameters of interest is absolutely first. It seems trivial, and in some case maybe it is, especially in some of the homework exercises. It might be very straightforward and easy to figure out. And then determine the function of the parameters and the distribution of the data. What that means is, are we talking about differences in means? Is it something else more complicated than that? Is it, if it's single sample, well then where are we going with that? And so there's a little bit of combination of 2 and 3 here at work here, because we need to know what other parameters need to be estimated. Do we have a small population size? Do I have to think about t distribution instead of z distribution? What's the underlying distribution of the data? At least what do I think? Do I think I might have a normal type distribution? If I'm looking at variances, then I need to be thinking about do I end up with chi-squared in terms of the associated sampling distribution related to the sample variance? What's going on with that? You need to think really about 2 and 3 somewhat simultaneously in some ways, right? And then of course, once you've answered 1, 2, and 3 to some degree of precision, then you can select finally and conduct a test, right? And what you're going to find is in your textbook a couple of different summary tables that turn out to be very useful. Right? On page 395, you'll see table 10-5 that they call a roadmap to constructing both confidence intervals and hypothesis tests for the 2 sample case. Right? And so you'll see these function of the parameters to be bounded by either the CI or the hypothesis test going along here in different kinds of scenarios. So differences in means from 2 normal distributions, or 2 arbitrary distributions but with large samples sizes. Right? Difference in the means from 2 normal distributions, or difference in means from 2 symmetric distributions. So there's a variation here. Now we didn't address this one here. Right? This is a rank sum test from a non-parametric procedure. So for the purpose of the class, you don't have to worry about this one, but from purpose of a big picture, you might want to look at that in case you ever want to do something that fits the Wilcoxon rank sum test, right, in this non-parametric approach. Right? Non-parametric just means can't use the parameters that we normally have been using. Right? And the list goes on and on here about for 4 or 5 more. So this is a roadmap that can be useful. Gives you a clear indication that you're looking at differences or proportions or ratios of variance, that sort of thing, and the parameters that are also important. And notice difference between population values being known or not knowing or essentially known. These are all important in terms of which one do you end up using. Now here in this table they tell you which section to go for. What I would suggest that you consider doing is taking the same kind of table and using your own shorthand, come in here and replace these things with sections with something a little bit more concrete. For instance, but maybe not quite as exhaustive as what you find on the back cover of your book. Right, so I'm assuming, of course, that you have a book, and you might not. You might have the e-book, and so you'll have to find the equivalent, of course. But in that back cover, you've got the same kind of thing that we had for the 1 sample, summary of 2 sample hypothesis testing procedures, these various cases, right? And here's the null hypothesis spelled out, here's the test statistic, and what the alternative hypothesis is, and then how you approach this, whether you're going to look at a fixed significant level criteria for the rejection or some equivalent way of looking at it in terms of the p-value. When the p-value is easy to calculate, then either one works really quickly. Sometimes the p-value is not so easy to calculate, such as when you get into the ratio of variances, right? And then you also have additional column there before the operating characteristic curve parameter, what that looks like. They've got that nicely spelled out for you. And then on the facing part of the inside cover, you have same kind of thing for the confidence interval procedures as well. So you might want to find a compromise between the previous table and this one, which is real spelled out in fine detail. And I say that from the standpoint of you'll want to, in practice, go away with a nice, easy to use reference that you can pull up and look at. And it works best when it's done in your own lingo, your own understanding and view of how all this stuff works. You could, of course, just copy these two and use them as is. I find one-page versions are more effective for my own work than having many pages of tables, which gets to be too much to filter through. I want something I can look at a glance and have a good sense of where I'm headed. Right? So that's best left to you and your own view of the world. As far as exams and what will be covered or available as authorized data on exams, I'll spell that out for you right on the exam cover, just like we've been doing previously, and that way you'll know as you prepare for the exam what you need to write down on your own separate sheets of paper. And typically I'm going to provide you with quite a lot of material here.